Hi everyone, this is Gaurav. Welcome to my learning channel. So in today's video, we will learn about graphical representation of the data. Now in your data science journey, you will realize that packaging and sharing the key findings are equally important as the analysis itself. And graph plays a very pivotal role to summarize and show some of the key trends. So without any further delay, let's get started. All right, so let's get started with the definition. Um, So the simplest definition that I could find for graphs is that graphs are the common method to visually illustrate the relationship in the data. This is probably the simplest definition that you will see, but if you go to Wikipedia and other sources, you will have like much more complex definition. But I feel like this does solve the purpose. So let's take a look at the example. On the left-hand side of the slide, on x-axis, you have number of years of bin, and then on y-axis, you have total net worth of a person. Now, this is the average for a particular population distribution. Now, as you can see that if you have a 0 to 5 years of experience on an average for the population that we studied, the average net worth was about $100,000. As we move to 5 to 10 years of experience, the net worth went up to $200,000 and so on. So once you reach to like 25 to 30 years of experience, your overall net worth for that population group was about $1.5 million. This is fairly intuitive as well. As you have more number of years, you save more, and that's why you invest more, and that's why your overall net worth keeps on increasing. But as you can see that this is not really a linear relationship. There is a little bit of a dip here, and then afterward it goes up. So this is one of the chart types, which is called line chart. And why do we need a chart like this, or why do we need any kind of a graphical representation? First of all, it will be very easy for you to summarize your findings. Let's say that if you see the same information as a part of the data, then you're probably looking at 100,000 different records, and it becomes very difficult to summarize and see like what's happening with the population. Second is it's easy to spot and showcase any kind of a trend. So in this case, you can easily make a statement when you're sharing the results that as the number of years of experience increases, then your overall net worth of a person also increases. And usually there is a linear relationship, approximately linear relationship, although there could be some distortion in the middle. It's also very easy to explain once you have a graph in front of you, and it's easy to quantify and compare amongst like two different population distribution and so on. So this is probably the simplest type of a graph. Let's take a look at some of the other ones that you would potentially use on your day-to-day. Now, a few of these I'll be using quite frequently as we move forward in the journey. So that's why I want to make sure that it is clear here. So on the left-hand side, we have a bar chart. In x-axis, you have 5 different group A, B, C, and D, and E. On y-axis, you have average marks by the students for that particular group. So say, for instance, for group A, the average marks is about 65. For group B, the average marks is about 75, and so on. Now, as you can see, just visually inspecting this graph, that group D is doing pretty good. Overall, they have the highest average mark. And on the other hand, group C needs to step up their game because overall their average is lowest. So this is very suitable for categorical data visualization. Let's say you have 5, 6 different groups or different sections or things like that, then you can easily do a visual inspection if you have a graph like this. But it does become very difficult if your number of categories are fairly high. So let's say that if I do something similar, but I do it for number of states in your country, let's say in the United States, that's like more than 50 states. So in that case, the number of categories will be very high, and then it does become very difficult. On the right hand side, you have a histogram. Now, histogram is very similar to your bar chart, but in this case, the only difference is that on x-axis, you have a continuous variable. So like say, for instance, in this particular example, this is a student-wise distribution. So people who have gotten marks between 1 to 5, that's about 5 people. 5 to 9, that's about like another like 10 people. 9 to 13, that's about 21 or 22 people, and so on. So this kind of a distribution is also called a population distribution. And this is one of the topic that I really wanted to introduce at this point in time, because this is something, the population distribution and the probability distribution is something that you will see a lot in your subsequent videos. So this is very good for a continuous distribution, although I feel like once you get to a probability distribution, you will see a line chart does a better justification, and it's easier to understand as compared to a histogram. The next one is a stack chart. The stack chart is very similar to the one that you just saw, which is your bar chart. But the difference is that you have one more dimension. So you have first dimension, which is your different groups. You have another one, which is for how many, like what is the overall average marks. But you have a third dimension added here, which is you have average marks for three different subjects. So you have subject 1, subject 2, and subject 3, which is denoted by 3 different colors. Now, a stack chart is very suitable if your overall the height of the towers are same. So like say, for instance, if you have certain distribution where everything sums up to 100 or everything sums up to a constant number, then it is very useful because in that case, you can show that any kind of a difference or distortion happens across different categories, then that is very easy to explain and showcase even with the visual inspection. But in a situation like this, it does become very difficult, and I'll explain you why. Let's take a look at example of group A. Now, overall, you can see that group B is slightly bigger than group A, but I cannot tell just by visually inspecting what is happening for the average marks for group 2, subject 2 for group A, and subject 2 for group B. Now, unless and until I actually add the data labels here with the exact numbers, it becomes very difficult. And that's one of the reasons why stack chart is fairly useful if everything sums up to a constant number, but it does become very difficult if the tower height is different across different groups. The next one is a pie chart, which is on the right hand side. This is a type of a chart which does make your overall presentation looks fairly good. So like for instance, in this example, you can see that you have a market share by 4 different companies, company A, B, C, and D, and everything sort of sums up to 100. So a graph like this or a chart like this is fairly useful if you have a constant number just like this, and everything sort of sums up to a constant, which could be your 100%. But the problem with pie chart is that it has a limited dimension. It has just one dimension, but it does take a lot of real estate. So as you will move forward in the journey, you'll realize that you would actually prefer the charts where you have more number of dimensions, so that you can share and showcase the findings that you have as a part of a one chart itself, so that you don't have to prepare multiple charts. So we will be taking a look at examples like that as we move forward. The next one is a waterfall chart. This is a very important chart, and I feel like that this is something that is being used lately a lot, especially if you have a particular portfolio or a particular process and you are the full owner of that, then this is something which is very useful. So let's take an example on this case. So over here, you have what percentage of prospects attrite as they go through the overall application journey in a particular website. So let's say if you are going on a credit card website, you have to go through like 3-4 different pages before your application process is complete. So that's what they're trying to show here. So overall, you have 100% of people coming in. About 25% of people are attriting right at the landing page itself. An additional 20% attrite at application page, and additional 25% attrite at application process. So as you can see that about 70% of people are already attriting even before they are completing the application. Now they might actually complete the application, still not take the product, or they might actually leave afterwards. But overall in the process, you can see that the inefficiency or the design itself is making people attrite, which is about 70% of the people. Now at this point, this is very alarming for any of the typical product. So if I'm the product owner, I would definitely do a more investigation. Is it the content on my website that is making people attrite, or is this something that is related to the product design itself and people are not liking it once they go through the details of the product? So something like this is very helpful, and you can actually track it over a period of time as well. So you can draw something like this every month, and you can see that how much improvement have I made month over month. The last one is a combination chart, and this is something that typically is being used a lot in a finance industry where I work. And the reason behind is that it does give you multiple dimensions to show the data. So let's take a look at the example over here. So on y-axis, in the left-hand side, you have the total waste that is being generated as a part of any process. This could be any process. Let's say you have a manufacturing plant, and then these are, let's say, metric tons of waste that you are generating. And on y-axis, on the right-hand side, you have percentage distribution for the same waste that is being generated as a part of the process. So for instance, for 2019, you have 500 metric ton of waste that was generated, and that's about, let's say, 5% of overall product that you generated. Now, just looking at the bar chart, you can see that the total amount of waste that is being generated across years is increasing. Now, if someone looks at just one dimension, then this is a very alarming trend. And anyone would ask that why is this happening? But if you look at overall trend, not just the total waste being generated, but also the waste distribution, then you can see that the waste percentage is going down across different years, which is a good trend. So basically, this is telling you a good story. The story here is that as year progress, your overall amount of waste has gone up, but overall waste percentage has gone down. Now, this can happen because of the combination of two things. One, this can happen because your process is getting more efficient, and two, it's also because you are increasing the overall volume of the product that you are generating. And both of these things are very positive story. So now you can see that adding one more dimension just completes the story. Otherwise, with just one dimension, it would have an incomplete story. And then you will have to have like another graph, another justification slide where you will have to kind of add all the details. So in my personal day-to-day life, I do use combination chart a lot. But again, different industries have different trends. So that's about it for the chart. Hopefully this gives you a good basic understanding of charts. In the next video, we'll continue our journey to understand more about stats. Thank you and happy learning.